another circle theorem proof here. This time we're going to take a peek at proving the alternate segment theorem. Now the alternate segment theorem says that when we have a situation like this, we've got three chords inside our circle, they form a triangle, and we have a tangent meeting one of the vertices of the triangle, then the angle formed at the intersection point is equal to the angle in the alternate segment. So it's probably clearer to see what that means by looking at this picture. So this red angle down here at the intersection of the tangent and the chords is equal to the red angle in the top right of the triangle, and the green angle at the intersection is equal to the angle at the top left of the triangle. So let's take a peek at how to prove it. Now this probably is the most complicated circle theorem to prove. There's quite a lot to it, so to cut down on my terrible handwriting, I have gone ahead and done a bit of labelling and stuff already. So let me talk to you about what I've done so far. So the first thing that we need to do, when we've got our triangle inside the circle, we need to put a point inside it to represent the centre. Now it doesn't need to be deadly accurate because we're proving this algebraically. We're not measuring anything. So pick a point inside the triangle as a centre. Now from this point, draw a line out to each vertex of the triangle. So that's what my green lines here are. They all meet at the centre. So each of these green lines is going to be a radius of the circle. And that means that each of these triangles is going to be isosceles. Now it's not to say they're the same isosceles triangles. So what we do with each triangle, we label the two equal angles A, B and C in each triangle respectively. And then we need to label the centre angles as well. So in the A triangle, for example, to get 180 minus 2A, we know that angles in a triangle add up to 180. So we know that those two A's add the central angle equals 180. So that central angle is equal to the difference between 180 and the 2A. So 180 minus 2A. So that's where these labels have come from. So the first thing that we're going to do is label this angle here X and this angle here Y. Now we need to notice here that this green line that comes down to the vertex at the intersection with the tangent is a radius. Now a radius and a tangent meet at right angles. So that tells us that X add C is equal to 90, and also then that Y plus A is equal to 90, the two angles at the intersection of the radius with the tangent. So those two are going to be useful to us. The next thing we need to do now then is work out what it is we're actually trying to prove. So we're saying, well, we're trying to prove that X is equal to A plus B up in the top right. And we're trying to prove that Y is equal to B plus C over in the top left. So that is what we're trying to prove. Let's get to proving it. Okay, so to prove it, we need an expression for, we need an equation in terms of A and B and C. And once we have this equation, we'll be able to use these two bottom equations simultaneously to prove what we're trying to prove. So, using the central angles, we know that they are angles around a point, so they would total 360. So we got 180, add 180, add 180, that would give us 540. So we know that 540 minus 2A minus 2B minus 2C is equal to 360. So again, that's just come from summing those three central angles. If we take away the 540, we'll get minus 2a minus 2b minus 2c is equal to minus 180. Now in that equation, we have a common factor of minus 2 running through the whole thing. So if we divide by minus 2, we'll be left with a plus b plus c is equal to 90. Okay, so we need that equation, and we're going to use that with these two equations down in the bottom left. So, if we look at the x plus c equals 90 equation, if that's equal to 90, we also know that a plus b plus c is equal to 90. So if both of these things are, if both of these expressions are equal to 90, we know then that these expressions are equal to each other. So in other words, a plus b plus c is equal to x plus c. So if we write that in, a plus b plus c is equal to x plus c. And then if we take away that c, we get a plus b is equal to x. And we wanted to prove that. That was one of the two things that we wanted to prove. Very similarly, y plus a is equal to 90. And again, a plus b plus c is equal to 90. So if both of those expressions equal 90, then they equal each other. So we can say then that a plus b plus c is equal to y plus a. Then if we take away the a, we get b plus c is equal to y, which is the second chap that we were wanting to prove. There you go, guys. We have proven the alternate segment theorem. At the end of a proof, you can always put a cheeky little QED for quite enough done.